today. Don't sit there and get so bored that you quit listening, because it's going to get you in the end. All right, here we go. I am hoping to get through this section, but if not, let me set the timer, then we'll continue it tomorrow. I'm always fair. I will give you plenty of time to do work in the classroom. I will never give you like 5 minutes and say you're done. All right, so today we're doing 3.3. It's similar figures. And scale models. All right, 3.3, similar figures and scale models. Okay, in your book for this one, there's going to be a lot of examples that are already done for you, but we're going to go over them together. All right, we're going to go over them together. All right, the first thing you need to know are what similar figures are. You need to know the definition for this. They have the same shape, but not the same size. Now, Matthew, if you want to move up and sit in Keith's desk, you can. Or Sam, either one of y'all. New?
Me moving up isn't going to make me understand it any different.
Okay. Yes, New?
Same shape and
Right. The same, the angles are going to be the same. No. I'll show you just a second. Similar polygons.
what's a polygon again?
Close-sided figure. Straight lines.
Okay.
So no circles, nothing that has an open or break in the shape. It has to be
straight and it has to be
straight lines and it has to be closed figure. Good question.
so most things are polygons.
Well, a lot, like in geometry.
Like a regular old.
It can be an octagon. It doesn't even have to have all the same size edges. It can be a weird looking shape as long as they're all straight and it's completely close. Like there's no, like I said, no break in it.
So a line is not a polygon.
No. Okay, so polygons in which corresponding angles are congruent. There you go. And congruent means equal. And corresponding sides are proportional. So this is where 3.2 and 3.3 have in common, is that whole proportion thing. And that's like I was telling Matthew yesterday. The converting that we did, that is difficult. It's not the easiest thing. Some of you may say, no, I've kind of figured it out. Okay. But for some, that's very difficult to do all that converting, right? Guys, keep in mind there were 2 problems out of all of those problems yesterday that you had to convert. So do not freak out and quit over just one little aspect. 2 questions and all of the stuff we did yesterday. I even told Matthew, I said, you know what's really important that you need to know? And I told him proportions. Proportions, we're going to see like today, and you're going to see in other sections. you may not see conversions for the rest of the chapter. You have to know it, but proportions is probably a little bit more important. So I told him, I said, focus on that last night. Focus on the proportions. If you get that, then if on the test you miss the 1 or 2 conversion questions, it's not going to hurt you, right? Right? In fact, I may even have only 1 question on the whole test about converting. So don't freak out. All right, does everyone have this written? If not, y'all need to speak up. All right, so moving on. All right, so those are your similar figures, similar polygons and similar figures. Okay, you have to know what the property of proportions is. In a proportion, the product of the extremes equals the product of the means. That's the definition. Property of proportions. In a proportion, the product of the extremes equals the product of the means. What does product mean? Answer to a multiplication problem means you're multiplying. So, product of the extremes equals the product of the means. You know what that means? Get it? Cross multiply. I have no idea. I don't know. And you know what? I don't care. I don't care which is the means. I do not care which is the extremes. All I know is that we're talking about proportion and you're cross multiplying. As long as you know that, you're good.
So that's the property of proportion.
Cross multiply.
So all those words don't really matter when cross multiply?
I have to introduce it to you. But you need to know that when dealing with similar figures and polygons, stuff like that, you're going to be cross multiplying. So what we're doing in this section is cross multiplying. We're going to be cross multiplying a lot. That's why I was emphasizing that yesterday. Cross multiply. Does everyone have this?
No.
Okay. I will leave it up there. Take your time. I want to make sure everyone gets all of this down. You have it? You have it? All right. Now that everyone has this, we're going to look at example 1. Oops. In your book on page 106. So everyone needs to open to page 106.
Oh, wow, we've never done one of these.
Now, these are good examples. Unfortunately, well, yes, of course I give you the answer, but it's hard sometimes to figure out what these examples are saying. So, a long time ago when I started teaching out of this book, I decided, you know what, for this section, we're going to use some of these examples so you understand. Now, again, you're going to write what I write to help you out, even if it's in your book. Okay? So example 1. The question says, find x, y. So that's our goal, is to find x, y.
Okay.
It says, given the measurements of the two similar triangles. Now, I'm going to draw over here the two similar triangles. They are not going to be perfect. Notice that similar triangles, one's usually, they're identical, but one's larger than the other. Okay, that's the best I can do. Oh, that looks nothing like it. Okay. X, Z, and Y. A, B, and C. They tell me that
So how about the M's in the middle?
the what?
So like on the little triangle, there's M.
Oh yeah, I'm about to do that. There, this side is M measurement. We don't know what it is. This side right here is 2.5. Okay, so this side is 2.5. This side is M. They said this side is 5, and this is 5.7. Okay, and they want us to find XY, which is M. They don't have a measurement there.
Don't need it.
Okay, yeah, you really don't need it. So what you're gonna do to find this is you're gonna set up a proportion. Nope, you're gonna put your hand down. I'm giving notes. No, the answer's in the book, Franz.
I know, but I don't
Okay, so we're going to set up a proportion. A proportion, if you remember, is like a fraction with an equal sign. You're going to stick to the sides that have the already given measurements. The same sides. So if you notice, X and Z and A and C are corresponding sides, right? So we're going to put the bigger triangle on top, and it corresponds with the smaller triangle. So this side is going on top.
Can you do that one?
Okay, so you see my proportion, right? Okay, so we're going to be able to get this, we're going to start with the two sides that have measurement already, that they gave us. This side goes along with this side, right? Because they're like the same size, just one, same side, one's bigger than the other. So I'm going to set it up as a proportion. I'm choosing the larger side to go on top, CA, and then the corresponding smaller side to go on the bottom.
But the smaller side could go on the top if you wanted it.
Bingo. The smaller side could go on the top and the larger on the bottom. But when you come to this proportion, this side over here, Sammy, you looking? They have to match. If you put the big on top, then the big goes on top over here. If you were to decide to put the smaller on top, then smaller. They have to stay together. So,
But if you're cross multiplying, when so like when you're cross multiplying, you would put the CA on the bottom of the other.
not necessarily. It doesn't really matter which one you put as long as you correspond to the other. Watch what I do. So if I had the larger on top, I got to make sure that the other side is large. So we're trying to now find this measurement using this side. See how they're the same? So if I have the larger on top here, I'm going to put AB on top here because it's large. And then XY down here.
So it's like we're solving for M.
We are solving for M. You're absolutely correct. We're solving for M. So now now notice that large, I'm going to write that. Large and large. So we have to keep the largest together and we have to keep the smalls together.
Why would you do it this one solve for him.
Yeah, but we have to use, we're doing proportions. So we have to use the side that corresponds with it. See, X, Y, and AB are corresponding sides. They're the same. They're just different sizes, but they're the same side. So then all we do is plug in the numbers. Side CA is 5. ZX is 2.5. Y'all see that? So Matthew,
You're keeping it the same, but just changing it to numbers.
yep, now I'm plugging in the actual measurements. So Valeria, what measurement is AB?
Wait,
You can use that desk actually. Okay, Valeria, what measurement is AB?
2.7.
That's a 5.
I mean, yeah, 5.
Okay, so then I have 5.7 on top. And Sam, what do I have for XY?
M.
That's right, so XY is M. Matthew, do you see what I'm doing here? So you first try to find the sides that already have measurement, corresponding sides. And I set it up, large and small. And you can flip it, doesn't matter. And then the next two sides. And if I'm going to put the large one on top, then I have to put the large one on top over here. Now we cross multiply. Guys, Matthew, Sam, everyone, chat. If I write arrows on here, you are too. We are cross multiplying. Notice my arrows are going up. What is M times 5?
5M.
See, I'm writing it on this side. I'm going to put it in a bubble this time. What is 2.5 times 5.7, Morgan?
14.25.
14.25. I'm putting that in a bubble. Notice, here's my equal sign. The 5M is on this side. Do y'all see that? So I'm writing 5M here. 14.25 is on this side, so I'm writing it here. Now I can solve for M. And how do I do that, Miranda? I'm dividing by 5 on each side. And your book actually does give you the answer. And remember, y'all can use those calculators. M is 2.85. And that's how you solve for all these different sides and angles and everything. You're setting it up as a proportion. What's important, guys, is if you start with the large on top, small on the bottom, then the next side better have large on top. If you switch them, and it happens, if you switch them, you'll get wrong answers. New.
So I was doing the actual today, but I did a different way, but it still works.
Oh, it did?
Yeah.
Good.
But instead of 5 over 2.5, I think 5 over 5.7.
Okay, so what she did was she switched up, and I actually have that on here. So what she did is she chose to, and I don't want to mess this up, but this is another way of doing it. If you want, she did large, like it'd be a large triangle. Let me show you. Okay, so she chose to do a different proportion. It's up to you on this part. So she chose to do the large right here. Let's say 5 over 5.7. So she put this side here. Y'all see this? This side down here. But then this side is this whole section here is gonna be the smaller triangle. So if this side and this side correspond, then 2.5 need to be here, and then M needs to be here. So you could do large triangle on one side and small on the other. So that's the second way of doing it. And then you cross multiply. You will get the same answer. Because if you look, see this proportion? You're still doing the same thing. 5.7 times 2.5. 2.5 times 5.7. So you're going to end up with the same answer. Any questions? All right. Now let's look at example 2. On page 106. We're doing another one. This time it says find that measurement, then find the perimeters. Meaning you have to add up all the sides. Find N, then find perimeters. Now I'll draw the triangles. This will be X, Z, and Y. And they gave us 2.5. You can look in your book. 2.85, and then N is down there. And then the larger triangle. I know it doesn't look like it. I don't care. This will be A, C, and B. I don't know why they did that either. And they gave us 5.7, 7.25, and 5. Okay, so there's multiple ways of doing this. We have to solve for N. So let's see. Matthew, you want to try this? After you copy all this down, you tell me what to do.
Start.
We're going to set up a proportion. All right. Which sides do you want to compare?
A and C and X and Z.
Okay, so he's going to take the large side here because there's a given measurement and it corresponds with this one that has a given measurement. So AC and XZ. So the large on top, he's got small on the bottom. I'm going to say large and small. Okay, so then Matt, what would I put up here?
AB.
Well, what are we trying to solve for?
N.
N. So what large side corresponds with this side? So what, this is the small one, right?
Oh, well, I didn't write it.
So if this
I
is,
didn't write N down, so that's why.
oh, okay. So this is the side we're looking
So
for.
you can put down CB.
Perfect. CB, because this big side right here is going to correspond with that little one. So what would I put down here?
Z1.
That's right. Perfect. All right, so now we just plug in our numbers. So AC is 5. XZ is 2.5. CB, and again, notice he's got the large on top. It's 7.25. And then we have N is what we're looking for. So what do I do now, Matthew?
Cross multiply.
Perfect. Draw your arrows, guys. So then 5 times N is what?
5N.
And I put it on that side, and I've got a bubble, putting it on this side. Because see, we're multiplying going up, N times 5 or whatever, so it goes up there. 2.5 times 7.25. Are you leaving?
Yes, ma'am.
Okay.
You go. Fix it.
All right. So, anyone have that? Morgan?
18.125.
Okay, does everyone see where we're getting this? If you don't, you need to say something. Yes?
Do you know if the ghost is like allergy based?
Yeah, she does. Hurry. So, Matthew, what do I write now?
Write it out as like a problem.
Yeah,
So 5x,
5N.
5n equals 18.125.
Perfect. After you write that down, Matthew, tell me what I need to do.
Divide by 5.
That's right. Intruder alert. We're dividing by 5. And so N equals 3.625. Huh? So then we now know that N is 3.625. So we solved that. But they said to also find perimeter. Perimeter, if you remember, is when you add up all the sides. And this is easy, but I want to show you how they wrote it in your book. P is perimeter. So the perimeter of triangle ABC. So perimeter, that's what that big old P there is for, of triangle ABC. All you do is you add it all up. All the sides. 5 plus 5.7 plus 7.25. Yes, Chad?
The way that that's written with the capital P and the ABC, it looks like it implies that A, they should be multiplied.
It looks like
Or it should have like the triangle sign or something.
Oh, I agree. I agree.
it almost looks like they're trying to distribute them.
Right. But that's why I'm explaining the examples, because examples in your book, when I first saw it, I was like, what? What is that? Okay, now I know. They're referring to the perimeter of triangle ABC. You add up all the sides, you get 17.95. And then the perimeter of X, Y, Z. You add up all the sides. 2.5 plus 2.85 plus 3.625. And for time's sake, your book's already got it written. There you go. Now they went forward with all these weird proportional checks. Don't worry about that. Don't worry about that. I just want to make sure y'all understand what perimeter is. It's been a while since some of y'all even heard that word, so I want to make sure that we remember that. Are there any questions?
So you don't do anything after that?
No, you just answer the question. We did. You add the three sides.
I mean, 17.95.
No. Unless they say, what's the total perimeter of both triangles? Any questions? All right.
Couldn't this be considered scale?
Well, the whole title is Similar Figures and Scale
No,
Models.
but couldn't similar figures be considered scale model?
Because you're scaling down or up, right? Yeah, exactly. Okay, I'm trying to decide if I'm gonna do this next example here, if I'm gonna blow it off. No. I might. Oh, I can't. Okay, so we gotta do it. All right, so example 4. On page 108.
108 or 107?
108.
Oh, example 2.
Yep. Okay, here we go. Morgan, why don't you read this?
Instructions.
Mm-hmm. I need y'all to really pay attention. This is a lot.
Two similar rectangular prisms have corresponding edges in the ratio 2 to 3.
Okay, that's important. I want you to underline or star that the ratio is 2 to 3. That is important. You need to know that. All right, continue.
The area of the base of the smaller prism A's is 36 units to the power of 2
Squared.
squared. The volume of the larger prism, VL, is 1,215 units
Cubed.
cubed.
Volume is always cubed. Area is always squared.
Find the ratio of their areas and use proportion to find the area of the larger prism's base AL.
Okay, stop right there. So we're going to start with A. It says find the ratio of the area. So we're looking for ratio of areas. When we're doing this, how do we set it up? As a what?
Ratio.
And it looks like this. Make sure you keep that in mind. Okay, so when we set this up, watch how I do this. The area of the smaller figure, that's what the S is. Area of the smaller figure, I'm going to put it over the area of the larger figure. Now, question. Why do you think this ratio right here is important?
What is that number?
Those are your numbers. So they're asking for what's the ratio of the areas. Just the areas. The ratio of the two figures is 2 to 3. They're wanting to know for A, what's the ratio of the areas, and for B, it's going to be the volume. A with the little s, that's area of the small one, which we don't know. And then A to the L is area of the large. So we're setting up the just like we did before. Area of the small is on top this time. Area of large is on bottom. We're going to put this ratio in here. So where do you think the 2's going to go? The top. And then 3 goes in bottom because this is going to be your smaller. this is gonna be your larger. So that's why I have 3 on the bottom. This is your large, and it doesn't matter, you can switch them if you want. Now, Valeria, what do I do? Okay. Valeria, you probably wouldn't be able to answer that.
Right?
No, wait, hold on. When we're dealing with area, do we deal with square? That's why I'm saying take good notes. Do we deal with square or cubed?
Square.
So this ratio is going to be squared.
Why would you square the other one?
Why wouldn't you?
Yes, why would you-
Because there's no numbers here. We're trying to figure it out. We're trying to figure it out. So, does everyone see why I'm squaring it? Because we're dealing with area.
So if it's anything that ever has to do with area, how is it square?
You're going to square the ratio.
Is that a weird math? Or is that?
No, that's just the way, that's what I'm saying. If you have a problem with this, you're going to be using your notes. Now watch this.
How
What
are you getting the AS?
it was in our problem. Area, for the small figure is going to be A for the area of the small, area of large. Okay? Now, the ratio they told us is 2 to 3. So again, we are setting it up as a proportional, and area, we square it. So watch what I'm doing. I'm rewriting it. What is 2 squared? Matt, what is 2 squared?
4,
That's right. What is 3 squared?
9.
There we go. We have to square it. Okay, so now I have my new proportional. Right? Hello?
Now would you
Yeah.
cross multiply?
Wait, hold on. Morgan, read back the second sentence and look at all y'all, look at the directions. Read the second sentence, Morgan.
The area of the base of the smaller prism A is 36 units to its square.
Okay, stop right there. Do you see that, Matthew? I told everyone to read along.
The area of the base of the similar prism.
Smaller.
Smaller prism A is 36 units.
Okay, so that's where we got the A and the S, okay? So if AS, area of the smaller, is 36, we're going to replace this. So AS is 36 because they told us that in the problem. So Valeria, what am I missing?
The diamond, the line.
Did they give us that anywhere in the directions?
Oh, yeah.
They gave us the area of the large?
They didn't give you the area.
Oh, never mind.
They did. They gave us the area of the small, but not the large. So what can I put here? Yeah. Or,
0.
no, not 0. Yeah, let's put X. Because that's what we're missing. Chat.
I don't get why you would square the 36 at least.
Because it did say to the like squared, 36 units squared.
It's already square, basically, is what they're saying.
How is it already squared? And why
Because, read the thing. It says units squared. You're only squaring the ratio. So here's our new proportional. So Matthew, what do I do now?
Cross multiply.
That's right. Cross multiply. X times 4 is what, Valeria? 9 times 36. Anyone? Very good. So how do I write this, Valeria?
324 equals, 12.
Very good. Does everyone see that? Sam?
Yes, do.
Okay. I thought you were raising your hand. So now, Matt, what do I do?
Oh, you divide.
There you go. We're dividing both sides by 4. These cancel out. X equals 81 units squared. So basically, we can say that the area of the large figure is 81 units squared. So that's what we're looking for.
So that number is part of area, has to be able, you can, unsquare it.
But with area, it has to be squared, right?
So let's say it's 80, that wouldn't be the right answer.
No, it can be. It can be because you can have decimal type squares. So y'all are used to the easy perfect squares. Square root of 4, square root of 9, square root of 16. But in Algebra 1, that's gone. Okay, yes.
So, like,
I'm still confused. It says 36 units squared.
Yes.
Why would you square that?
That's the area. We're trying to find the area of the large one. They gave us the area of the small one, and that was 36. We're trying to find the area of the large one. We don't know that. And we have to use the ratio that they gave us. And because we're dealing with area, we only square that ratio so that it makes it proportional. If I didn't, it wouldn't be proportional. In fact, the next one we're about to do is going to be volume. Watch this. Does everyone have this down? Good. B is the same thing, but they're asking, they gave us a volume of what? Morgan? In the problem, they gave us the volume of what? In the directions.
Volume of 12, 15.
For, is that the small
Units.
figure or the,
large?
huh?
Large.
We're still in the same one.
The large volume is 1,000.
That's right. So then what are we looking for?
Small.
There you go. So we're setting it up. This time it's volume. We're setting it up just like we did above.
oh, the ratio of the volumes?
Bingo. Yep. So they gave us the large. This time we're looking for the small. But first we have to set up our ratio. So Miranda, what's my ratio again? The original? What is it? What's the ratio at the very beginning of the very first sentence? What's the very first sentence? Ratio is what of these two figures? 2 to 3. So we're going to compare the volume, the two figures volume to the original ratio. The ratio said 2 to 3. Now, Miranda, this time we're doing volume. What do I do with my ratio? If we for area we squared it. For volume, what do we do?
Cube.
You cube it. Very good. Because it's volume, we're going to cube it. So make sure you see that. That means volume. All right, so let's find out what that is. Volume small, volume large equals, what is 2 cubed?
8.
And what is 3 cubed?
27.
There we go. Y'all have this down. Any questions so far? This is just like the other one. Now, Morgan, you said they gave us the volume of the large.
Oh, we're finding it.
It was 1215. And then we just bring down our ratio right here. Now we could put X here if y'all want. But if that was confusing you, we can keep it at volume small.
I
So-
like the X better.
Okay, it's whatever y'all want. So Sam, what do I do now?
What you do next is you cross multiply.
So 27 times small volume gives me what, Matthew?
27.
Yeah, if you want to call it X, that's perfectly fine. We can say that's an X right there. Same thing. And then 1,215 times 8 is 9,720. Okay, so Valeria, what's my new sentence?
You get 9,700.
27x equals 9,750. Then you divide 27.
Both sides by 27. You're correct. Intruder alert. And my X or my volume is 360 units cubed. So the volume of the small, we can rewrite it as 360 units cubed. Hopefully you've got good notes. Any questions? Does it make a little bit more sense now than when we began?
Yes.
This is like totally different from what we did yesterday.
Yes, of course. Each section's totally different. But we're still cross multiplying. Any questions? Oh, I know. I told y'all this whole chapter is ugly. Yes, Miranda.
I still don't get what I didn't understand earlier.
What?
It says it's cube or square, whichever for volume. It says it's.
You're only cubing or squaring the ratio. And the ratio at the beginning says 2 to 3.
In the directions, it says 1 to 12 units.
That's the volume for the large. That's the volume for the large that they gave. See? 1, 12. They gave that to us. Just like right here, 36. They gave us in the directions the area for the small figure. You don't have to square it or cube it. You don't have to do any of that. You're only squaring and cubing the ratio.
You know what it says?
It didn't. That's the way it's read. That's just its units.
Okay.
Does that help? There you go. Good. Chat.
So if you have 60 units and it says to find, no, not 60. Well, let's say you have 6 units and it says to find the volume. You would cube that.
You'd have to cube the ratio. If they have 60 units, that's not telling me anything. How can you can't find volume by just telling me they have 60 units? I mean, what is that? Area? Or what? I don't understand what you're telling me. That's not that what I'm saying is that's not a problem that can be solved. I think you're reading too much into what they're giving you. They're just giving you the measurements.
So I understand it. I understand.
Okay.
But if you're going to find volume, how many different numbers do you need?
You don't need different numbers. All you need is the ratio.
Ratio of what?
They gave you the ratio at the beginning of the thing, the ratio between the two figures. The very first sentence. That's all you need. Because that's what we're looking for. You need to know that ratio to be able to find the volume of the other one.
And you need to at least have at least one like volume of the larger.
It's kind of like when we were comparing these sides. You have to be to be able to find this. We had to be given something already to compare it to, right? Okay. Well, this is the same thing as them saying, well, you know what? Because we're dealing with all, not measurements of sides, we're dealing with area and volume. They went ahead and gave us the ratio, and we just plugged it in and compared, and did our cross multiply.
Oh, hold on. Okay, so let's say you have a box, and you have
Keith, you can go. In fact, I'm going to stop this video.